Hello everyone, welcome back to Amaze. So in this video, we are going to start with chapter number 7, Coordinate Geometry. In this video, we'll first see the distance formula, how to figure out the distance between the given 2 points on the graph, and then we are going to solve few important questions from exercise 7.1. So let's begin. So here the first task is we are going to find the distance between the given 2 points on the Cartesian plane. So we have here x-axis as well as the y-axis, right? Let's say if I have randomly any 2 points, let's say point P which is 4, 5 and point Q which is 6, 8. I want to find out the distance PQ, right? So I cannot use scale and directly measure what is distance PQ, right? Because whatever the given figure is in the examination will be not up to scale, right? Figure to scale, right? So basically, if there is any coordinate mentioned to you, okay, let's say any point x, y and the other point x, y, how to find out the distance between them, right? So let us see first taking this values. Let's say if I have a point 4, 5 and 6, 8, what is the distance between these 2 points, this distance? How to figure out algebraically? Okay, let's see. First, can I write that if this point is 4, 5, this point is 4, 5. What will be the coordinate here? This will be 4 and this will be 5, right? This will be 4 and this will be 5, right? Similarly, for Q, 6, 8, here on x-axis it will be 6 and here on y-axis this point will be 8, right? So let me first write this down. Okay. So first of all we have here, let me draw a line. Okay. This one is going to be 4 and this one is going to be 6, right? 4 and this should be 5 and this is 6, this should be 8. So let me write down 6 and 8 now. Okay. So 4 and 6, so sorry, now 5 here, 4, 5, so this will be 5 here on the y-axis. And this is going to be 8 on the y-axis, right? Okay, this is going to be 5 and this is going to be 8, right? Now, look here, what I'm going to do is, I will draw a line parallel to the x-axis. I want to figure out distance PQ, right? What I'm going to do is, I am going to draw a parallel line here. Okay, parallel line here. Let this be intersecting this line. Okay. Now, let this point be, let this be T, let this be R, and let this be S. Clear with the figure? What I've done here is, here I've taken this as P 4, 5, so this is 4 obviously on x-axis and this is 5 on the y-axis. Similarly for Q, this is 6 on the x-axis and this is 8 on the y-axis, right? Then only we have this as 6, 8 and this as 4, 5. Now, I've drawn a parallel line to x-axis, okay, and it is intersecting this one at T. Now, what can you say about this angle? This angle is going to be 90 degree, right? Because this line, blue one, is parallel to the y-axis and this line, obviously I have drawn it parallel to x-axis. So obviously this angle is going to be 90 degree, right? Now, what was our initial task? Our task was to figure out the distance between P and Q, right? PQ, distance. So now look at this triangle PTQ. Is it a right angle triangle? So in this right angle triangle, if I will have these two sides, this one and this one, will I get the hypotenuse which is nothing but PQ by Pythagoras theorem? Yes, I can get that, right? Okay, so here this point is P, this is T, Q, R, S. Now what I'm going to do is, what will be distance PT? What will be distance PT? PT distance is nothing but 2, right? You can see here. What is this distance PT? It's 2. Why 2? Because it is 6 minus 4, which is 2, right? And this 6 is nothing but the x coordinate of the second point, and this 4 is nothing but the x coordinate of the first point, which is P. So 6 minus 4, which is 2. So this, obviously this distance PT is going to be 2. Now let us look at this distance QT. What is this distance QT? It is 8 minus 5, 3, right? This distance is 3, which is QT. Okay. Now, what is this 8? It's the y coordinate of the second point, and what is this 5? It's the y coordinate of the first point. Okay. Subtracting it, we got this distance, which is 3, and this distance is 2. Now we have two sides, this 2 and this 3. Can we figure out the hypotenuse? Yes. Okay, by Pythagoras theorem, as it is a right angle triangle. So let us figure out, in triangle PTQ, in triangle PTQ, what we can write down? PQ square, which is the hypotenuse square, is equal to PT square plus QT square, right? This is what the Pythagoras theorem is, right? That the square of the hypotenuse is always equal to sum of the square of the other two sides, okay, in a right angle triangle. So now what is PT? We know PT is 2. So let me write down here 2 square, plus what is QT? QT is 3. So this is going to be 3 square. What is 2 square? It's 4. What is 3 square? It's 9. What is 4 plus 9? This is 13. 13 is not the length of PQ. It is PQ square, right? PQ square. So now square will go on that side and it will become square root, right? PQ equals to square root of 13. If we take square on the other side, it becomes square root, right? So square root of 13. We got the length of PQ, which we were figuring out. PQ equals to root 13. So PQ equals to root 13. So that's the answer. Now here we have taken any two random points, P as 4, 5 and Q as 6, 8, and then we did this process to figure out the length PQ. Similarly, let us do the same steps with variables. Let us generalize it and let us come out with a distance formula. Okay, so let's do it. Okay, so as we were having 2 points, 4, 5 and 6, 8, I guess. Now to generalize it, what I've taken here is, let's say any given 2 points, okay, the first point be x1, y1, because it's the first point, so I name it as 1, 1, x1, y1, as it is x coordinate, y coordinate, and the second point is x2, y2 similarly. So let's say if I want to figure out the distance between these 2 points, PQ, okay, let us do the same process and we will get a generalized formula for the distance between 2 points. So let us do it. If this is x1, y1, obviously I can write down this as x1, okay, and here it will be y1, right? And here x2, y2, so this point will be x2 on the x-axis, right? Similarly, if this is x1, y1, this will be y1, okay, so x1, y1, and this is x2, y2, right? Now, let us do the same process. We have a right angle triangle here, which is QTP, right? We want these 2 sides, PT and QT, and then we can figure out the distance between PQ. Our aim is to figure out the distance PQ, right? So now here, what is PT? What is PT distance? PT. PT is nothing but this distance, and this distance we already figured out in the last example, which was this number minus this number, right? Here it was 4 and I guess here it was 6. So 6 minus 4 was 2. So now we have x2 and x1. So PT will be x2 minus x1, right? As simple as that, the subtraction of both of them. x2 minus x1 will be this distance, rs, or I can say pt, right? Okay, similarly, what will be this distance, qt? Qt will be y2 minus y1. Qt will be y2 minus y1, right? Because we were having initially 8 and 5. So we subtracted 8 minus 5, which is 3, this distance. Similarly, y2 here and y1 here. So we'll subtract it, y2 minus y1 will give us the distance qt. Now we have pt, we have qt. Can I figure out pq, which is the hypotenuse? Yes, by Pythagoras theorem. So in triangle PTQ, the hypotenuse square, which is PQ square, is equal to sum of squares of other two sides, which is PT square plus QT square, right? So PQ square equals to PT square plus QT square by Pythagoras theorem, right? Now, what is PT? PT is x2 minus x1. So let me write down, this is PT square, right? Let me write down PT as x2 minus x1 plus this is QT square. So QT square. What is QT? It is y2 minus y1, right? So y2 minus y1 written, okay? This is nothing but PQ square. Now if I take square on the other side, it becomes square root, right? Okay, so it will be square root of the whole RHS. So this comes under the root. So PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So we got PQ as the whole root, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the distance PQ, and this becomes the distance formula. So now if you have any 2 points on the Cartesian plane, wherever it is, you can figure out the distance between those 2 points using this formula, okay, which is known as distance formula. Let us quickly check by this formula, are we getting the same answer which we figured out before this? Okay, I think we got root 13 as the PQ distance, right? So let us quickly check it here. Okay, point P was 4,5 and Q was 6,8. Okay, so as I told, the first point will become, this will become x1, this will become y1, this will become x2, and this will become y2. Let us find out the PQ distance using the distance formula. It is root of x2 minus x1, x2 is 6, minus x1 is 4, the whole square, plus what is y2? 8, minus y1, which is 5, the whole square. It is equal to root of, what is 6 minus 4? It's 2, and the square remains as it is, plus what is 8 minus 5? It's 3, and the square as it is. Okay, this is equal to root of, what is 2 square? 4 plus 3 square, 9. What is 4 plus 9 inside the root? It is root 13, right? We got the same answer using the formula also, right? So now no need to make figure like this and then figuring out which is the triangle forming here and then applying the Pythagoras theorem and getting the answer. We can directly use the distance formula whatever the coordinates of the first and the second point is. Clear? So in this way we can figure out the distance using the formula. Now based on this distance formula we have exercise 7.1. So let's do some important questions from exercise 7.1. So the first important question from exercise 7.1 is question number 6. In it, I have taken the first part. So here, what is given in the question? Name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. So we have been given points and we need to see that points, if you join it, okay, you have the points on the Cartesian plane. If you join it, what type of quadrilateral it is forming, if it is forming any, right? So we know there are different types of quadrilaterals like square, rectangle, rhombus, kite, parallelogram, and so on, right? Trapezium. So we'll try to figure out, if we have these 4 points, what type of quadrilateral it is forming. So the first one is where the points are -1 comma -2. Okay, the names are not given. Let me name it as this as A. Second, the B point is 1 comma 0. C point is -1 comma 2. And D point is -3 comma 0. Okay, now let's see what we are getting it here from this given points: -1 comma -2, 1 comma 0, -1 comma 2, and -3 comma 0. So these are the 4 points. Now let us see and figure out the lengths of the all of the 4 sides, because we can have 4 sides after joining this, right? AB, BC, CD, and DA, right? So if we'll join all of these 4 points, we have 4 sides, right? A to B, B to C, C to D, and D to A. Let's check the length of it. Let's figure out the length of each side using distance formula, right? Based on the lengths, looking at the properties of different types of quadrilaterals, maybe we can come to a point which type of quadrilateral it is, right? So let us figure out the length of AB first using distance formula. AB will be equal to root of, as per the distance formula, it is x2 minus x1 the whole square. x2 minus x1 the whole square. What is x2? Okay, this is A point, this is B. So you can take this as x1 comma y1 and this as x2 comma y2. So x2 is 1 and x1 is -1. So x2 minus x1 the whole square, right? This is x2. Okay, let me have a bracket here also for your better understanding. x2 minus x1 is -1 the whole square plus y2 minus y1, which is -2 the whole square, right? This is y2 and this is y1. So what we are getting it from here, let's see. 1, okay, x2 minus x1. So 1 minus of -1, minus minus becomes plus. So 1 plus 1, which is 2. What is 2 square? It's 4. Plus 0 minus of -2, minus minus becomes plus. So 0 plus 2. 0 plus 2 is 2, and what is 2 square? It's 4 again, right? What is 4 plus 4? Root 8. So the distance AB is root 8, right? Let us figure out the length of the second side, which is BC. Now BC, in this BC, we can take B point as x1 comma y1 and C as x2 comma y2, right? Let us apply the distance formula for BC. So here it will be -1 minus x2 minus x1. x1 is 1, 1 the whole square plus y2. What is y2? y2 is here 2 minus 0 the whole square, right? This is y2 and this is y1, right? y2 minus y1 the whole square. So here we are getting -1 minus 1. What is -1 minus 1? It's -2. -2 square is 4, right? Because 2 square is also 4 and -2 square is also 4. -2 into -2, which is plus 4, right? Okay, so we are getting 4 here plus 2 minus 0 is 2 and 2 square is 4. So we are getting again 4 plus 4 root 8. So that means AB and BC are equal sides, right, in the quadrilateral. Now let's go for the third side, CD. Similarly, let me write down quickly x1 comma y1 and x2 comma y2. So -3 minus of -1. -3 is x2 minus x1 is -1 the whole square plus what is y2? 0 minus what is y1? 2 the whole square will give you as -3 plus 1. because minus minus is plus. Minus 3 plus 1 is minus 2. And minus 2 square is again plus 4. Plus 0 minus 2 is minus 2. And minus 2 square is plus 4. So you are getting CD side as root 8. Right? Now, let us figure out the fourth side, AD. AD. Right? So AD is what? Let us see. x1 comma y1 and this is x2 comma y2. So here again, let me write down x2 minus x1 the whole square. What is x2? Minus 3. And what is x1? Minus 1. Plus, sorry, this will be y2 minus y1 the whole square. What is y2? 0 minus, what is y1? Minus 2. So let's see what we are getting. We are getting it as minus 3 plus 1. Minus minus becomes plus. Minus 3 plus 1 is minus 2. Minus 2 square is 4 again. Plus 0 minus of minus 2. So 0 minus minus becomes plus. 0 plus 2 is 2. 2 square is again 4. So again we are getting root 8. 4 plus 4 is 8, right? Inside the root. So here we can see that all the four sides are equal. AB, BC, CD and DA. Right? If all the four sides are equal, there are two types of quadrilaterals. It can be a square or it can be a rhombus, because in rhombus also all four sides are equal, and in square also all the four sides are equal, right? So here, but we need to specify which type of quadrilateral it is. So now we are confused between two things. It can be a square or it can be a rhombus. But one of the property difference between square and rhombus is the diagonals are equal in square while the diagonals are not equal in rhombus. So what we are going to do here is, we will figure out the length of the diagonals. If they are equal, we will call it as square. And if the diagonals are not equal, we will call it as rhombus, right? Because from this we came to know that it is square or rhombus. Now to identify which square or rhombus, we need to check the diagonals length, right? Okay, just for your better understanding, let me draw the rough figure here. Okay, A, B, C, D. We have figured out A, B, B, C, C, D and D. A, B, B, C, C, D and D. All four sides are equal. Now what I am going to do is, to check is it a rhombus or a square, I will check the length of AC and I will check the length of BD. If this lengths AC and BD are equal, then it will be a square. And if they are not equal, then it will be a rhombus, right? So let's check the length AC. AC equals to root of x2 minus x1 the whole square, A and C. So I am taking this x1 comma y1 and x2 comma y2. So x2 minus x1 the whole square. So here minus 1 and minus 1. So minus 1 minus 1 plus y2 minus y1 the whole square. What is y2? 2. And what is y1? Minus 2. So 2 and minus 2 here. Okay. What is minus 1 plus 1? Because minus minus becomes 1. So minus 1 plus 1 is 0. Minus 1 plus 1 is 0. 0 square is 0. This plus as it is. 2 minus of minus plus 2 plus 2, which is 4, and 4 square is 16. So we are getting here it as 0 plus 16 is 16. Okay. So root of 16 is plus or minus 4, but we will keep it as plus 4 because this is length. Length of any side cannot be negative, right? It will be positive only. So AC is 4, right? Now let us take the other diagonal BD. So BD we are getting it here as B 1 comma 0 and D minus 3 comma 0. So x1 y1, x2 y2. Let us figure out the distance BD. So x2 minus x1 the whole square. So what is x2? Minus 3. And what is x1? 1. Plus y2 minus y1 the whole square. What is y2 here? 0. And what is here? y1? 0. right? It's minus 3 minus 1 the whole square, 0 minus 0 the whole square. We are looking at BD, right? Yes. So what we are getting it here is minus 3 minus 1, which is minus 4. And minus 4 square is 16, right? Because minus 4 into minus 4 is plus 16. So minus 4 square is 16 and 0 minus 0 is 0, 0 square is 0. So what we are getting, 16 plus 0 is 16 and root of 16 is nothing but 4. Now look at the lengths of the diagonals, AC and BD. They are same. So that means all four sides are equal as well as the diagonals are also equal. So that is only one quadrilateral which is square. So that means with these points the quadrilateral formed is a square. You can write down here with reason that as AB equals to BC equals to CD equals to AD, that is all four sides are equal, and AC equals to BD, that is diagonals are equal, we can say that quadrilateral ABCD is a square, right? Okay, so we have figured out what type of quadrilateral it is. It is a square. Again reiterating, we were given 4 points and we were supposed to identify what type of quadrilateral it will form, right? Okay, so we have the 4 points of the Cartesian plane. So what we have done here is, first we have figured out the lengths of all the four sides AB, BC, CD and DA using distance formula, right? Using distance formula, we are getting all the four side lengths as root 8. That means all four sides are equal, right? Now, if all four sides are equal, it can be a rhombus or it can be a square. So the different property of rhombus and square is there is a difference between the length of the diagonals in both of them. If in square, the diagonals are equal. But in rhombus, diagonals are not equal. So we have checked the length of the diagonals, which is AC and BD. So here, when we figured out using distance formula, we got AC as 4 and BD as 4. That means the diagonals are equal in length. So from here, we can directly say that as all four sides are equal and the diagonals are equal, the quadrilateral ABCD is forming a square, right? So yes, you can have this type of questions, but you should be very clear with the properties of different types of quadrilateral, right? So now let's move on to the next important question of this exercise. The next important question is from this exercise is question number 7. So what is given here? Find the point on the x-axis which is equidistant from 2, minus 5 and minus 2, 9. So basically our aim is to find a point on the x-axis, means there is a point on the x-axis which we are supposed to find. Okay, what is the condition given? That point is equidistant. Equidistance means at equal distance from which points? 2, minus 5. So 2, minus 5 is basically 2, minus 5 somewhere here. Let this be 2, minus 5. Okay, let this be point B. Okay, and minus 2, 9. Minus 2 is somewhere here, 9 is somewhere here. Minus 2, 9. Let this point be C, minus 2, 9. Okay, now these are the 2 points. And we have to figure out a point on the x-axis which will be at equal distance to this as well as to this. So basically, let's say I have a point anywhere on the x-axis, point A. So which will be equidistant from both these points. Equidistance means at equal distance. So basically from point A on the x-axis, the distance AC should be equal to AB. Right? Are you getting my point? So here we need to figure out that point. Now, there are infinite points on the x-axis, right? Okay, we cannot check that each point has a distance, what distance from here to here, okay? So we need to figure out the exact point where if we join this and join this, they are of equal distance. So what we are going to do is, we are going to use the distance formula here. Next thing is, we have to figure out a point on the x-axis, right? So x-axis always has a point number comma 0. Why? Let's say if I have a point here 3 on the x-axis. What are the coordinates of that point? 3 comma 0, right? Let's say if I have a point here, let's take minus 1. So minus 1 on the x-axis is represented in the coordinate form as minus 1 comma 0, right? So it's the number comma 0. There will be always 0 in place of y coordinate, right? Okay, so we have to figure out a point on the x-axis. So let the point, we can take it as, let the point on x-axis, let the point on x-axis which is equidistant from, let the point on x-axis which is equidistant from B 2 comma minus 5 and C minus 2 comma 9 B A x comma 0. I hope you understood this, what I have taken it here. The point which is equidistant from both these points, I have taken it as A, and the coordinates will be x comma 0. We do not know x, but we are sure about that this is going to be 0 because it's a point on the x-axis, right? So x comma 0. So we just need to figure out x. So then we'll get the coordinate form of A point, right? Point A. So here we know that the point x comma 0 on the x-axis is equidistant. So basically the distance from A to C, AC will be equal to A to B, AB, right? So as per the given condition, the distance AB should be equals to AC, right? Now, we know how to figure out the distance AB. Let us figure out distance AB. Distance AB, we have the coordinates A x comma 0 and B 2 comma minus 5. So if I want to figure out the distance between these 2 points A, B, we can use the distance formula, right? So let us figure out using distance formula the length AB. The length AB is, using distance formula, root of x2 minus x1 the whole square, right? So here, if I consider these 2 points, this is x1 comma y1 and this is x2 comma y2, right? So x2 minus x1, so 2 and x, x2 minus x1 the whole square plus y2 minus y1 the whole square. What is y2 minus y1? In this, y2 is minus 5 and here y1 is 0, right? So this is what distance AB using distance formula, right? Similarly, can I figure out the distance AC? Yes, we can figure out distance AC. Distance AC is between these 2 points A and C, right? Again, applying the distance formula. So it is x2 minus x1 the whole square, which is minus 2 and x here, minus 2 and x, plus y2 minus y1 the whole square. What is y2? 9 and y1 0, right? This is distance AB, this is distance AC, and that should be equal, right, as per the given condition. AB is equals to AC, right? Given condition in the question. So now let us try to solve this equation to get the value of x, right? So this is root here also and root here also. So what we can do is, if there is a square root of the entire LHS equal to square root of the entire RHS, then we can cancel the square roots. So square roots are cancelled. So we are left with only the parts which is there inside the square root. So this is 2 minus x the whole square plus minus 5 minus 0. What is minus 5 minus 0? It is minus 5, and minus 5 square is plus 25, right? Because minus 5 into minus 5 is plus 25. Square of any number is positive, right? Negative or a positive number, if we square it, it's a positive number, right? Equals to, this is minus 2 minus x the whole square. Minus 2 minus x the whole square, right? Plus 9 minus 0 is 9, 9 square is 81. Okay, now what can be done from here? 2 minus x the whole square is, if we want to expand it, we can expand it using a minus b the whole square identity, right? Please never do this mistake writing 2 minus x the whole square as 4 minus x square, okay? Because a minus b the whole square identity is, it's not a square minus b square, it is a square minus 2ab plus b square, right? So similarly, here 2 minus x the whole square, if we'll apply this identity, how it will look like? What is 2? It's a, and what is b? It's x, right? So a square minus 2ab plus b square, so x square, right? Because b is x. So this is what the expansion of 2 minus x the whole square will look like. This plus 25 remains as it is, equals to again a minus b the whole square, because I am just looking at this minus in the center. So it's minus in the center, a minus b the whole square. So what is before minus? It's a. What is before minus? It's minus 2. So your a is here minus 2. What is after minus? It's b. What is after minus? It's x. So your b is x, right? A is minus 2 and b is x. Let us apply the same identity. Let us expand this bracket. So it is a square minus 2ab plus b square, right? And this plus 81 remains as it is. Okay, let us solve this further. Okay, what is 2 square? It's 4. What is 2 into 2 into x? It's 4x, right? 2 into 2, 4 into x is 4x plus x square plus 25, right? What is minus 2 square? Minus 2 square is plus 4, right? Because minus 2 into minus 2 is plus 4. This is minus 2 into minus 2, which is plus 4 into x plus 4x, right? Basically minus minus plus, and 2 into 2, 4x plus x square plus 81, right? Now what we can do here is, let us try to figure out the value of x. Now here, this is x square. If I take this x square on this side, it will become minus x square. So this plus x square and this minus x square will be 0. So obviously, I am not writing it here, but it is going to be cancelled out, plus x square and minus plus x square, because this plus x square, if I take it on this side, it will become minus x square. So plus x square minus x square, 0. Similarly, you do not have any, okay, fine. So now let us try to solve this. Okay. 4 plus 25, which is 29. 4 plus 25, which is 29. And this minus 4x remains as it is, equals to 4 plus 81, which is 85. And this is plus 4x remains as it is, right? Solving further, we are just left with, I guess, 2 to 3 steps. We will get the value of x. Solving further, what we are getting here is 29 I am taking on that side, and this plus 4x I am bringing it on this side, LHS, right? Minus 4x as it is. Plus 4x I am taking on this side, so it will become minus 4x. Okay, this is the minus 4x which is there itself as it is. Taking plus 4x on this side, it will become minus 4x, equals to 85 as it is on this side. Taking 29 on this side, so it will become minus 29. So therefore, what is minus 4x minus 4x? It's minus 8x, equals to, what is 85 minus 29? So if you do this, it's 56, right? 56. 85 minus 29 is 56, yes. Okay. Therefore, what is x? 56 divided by minus 8. Minus 8 will go in division, obviously, right? 56 divided by minus 8. So x equals to plus minus becomes minus 56 divided by 8. 8 7 is 56, so 7. So you got the value of x as minus 7, right? So now from this, what we can say is which is the point which is equidistant from both these points? Here substitute x is minus 7. So minus 7 comma 0 is the point on the x-axis which will be equidistant from B as well as C. Okay, so your answer is, you can write down the statement as, okay, I'm not writing it here, you can write down the statement as, therefore the point on the x-axis which will be equidistant from 2 comma minus 5 and minus 2 comma 9 is minus 7 comma 0. I will just show it here. Minus 7 comma 0 will be on the left side, right? So here basically minus 7 comma 0 you will have a point. So this distance AC, okay, this distance AC and this distance AC and this distance AB are going to be equal. Right? Okay, and yeah, we were given this condition that this distance are equal. We were just supposed to find the coordinates of the point on the x-axis. Right? Again, let me take you through it quickly. So here we were given 2 points, minus 2 comma 9 and 2 comma minus 5. We were supposed to find a point on the x-axis which is equidistant from both these points, means which is at equal distance from both these points. I have taken that point A as x comma 0 because any point on the x-axis is a number comma 0. We don't know that number, right? So x comma 0. Now we know that this is at equal distance from C as well as B. So basically AB distance should be equal to AC. AB should be equal to AC. Now applying distance formula for AB, we are getting this, and for AC we are getting this. Now square root and square root will be cancelled out, so we'll be left with the inside part. Okay, now applying A minus B the whole square identity, which is A square minus 2AB plus B square, where we'll get this. Okay, then this plus 25 remains as it is. And when we'll apply the A minus B the whole square identity again here on the RHS, we'll get this part, and plus 81 remains as it is. Solving further, we got x equals to minus 7. So substituting x equals to minus 7 here, so A point becomes minus 7 comma 0, right? So hence we can say that minus 7 comma 0 is the point which is at equal distance from point C minus 2 comma 9 and from point B 2 comma minus 5. So yeah, this was one of the important question. Now let's move on to the other important question of this exercise. The last important question from this exercise is question number 8. So what is given here? Find the values of y for which the distance between the points P 2 comma minus 3, P 2 comma minus 3 and Q 10 comma y is 10 units. So what they are asking us is to figure out the value of y, right? So as per the question, find the value of y, values for y. So yes, we can have multiple values also. Distance between the points P and Q is given. That means distance PQ is given, which is 10 units, right? 10 units. Okay. So we know if 2 points are given to us, okay, all the means the coordinates x comma y and x comma y is given to us, we can figure out the distance. But here the distance is given and we have to figure out one of the coordinate here. So y coordinate of the point Q. So let us apply the distance formula and then let us solve the equation to get the value of y, right? Because we already have the distance. So how to figure out the distance PQ? We know that using distance formula, PQ is going to be root of x2 minus x1 the whole square, x2 minus x1 the whole square. So what is x2 here? It's 10, and what is x1 here? It's 2, right? Because this is x1 comma y1 and this is x2 comma y2, plus y2 minus y1 the whole square. What is y2? It's y here in this case. And what is y1? It's minus 3, right? So this is what we can do it using distance formula, right? Finding the distance between PQ. But we already have the distance PQ, which is 10 units. So can I substitute this as 10? Yes, I can substitute it. So equals to root of 10 minus 2. 10 minus 2 is what? 8. What is 8 square? 64. Plus this is going to be y minus of minus 3, which is y plus 3, right? Minus minus becomes plus 3 the whole square. Okay, so this is what we have. Now this square root will come on this side. So if square root comes on this side, it becomes square, right? So it will be 10 square equals to 64 plus y plus 3 the whole square. I have just taken square root on this side, so it becomes square, right? So 10 square is 100 equals to 64 plus y plus 3 the whole square, right? Now, next is, what we can do here is, either we can expand it, that is also one of the way, or either you can take 64 on this side, so which is 100 minus 64 equals to y plus 3 the whole square. What is 100 minus 64? It is 36, right? 36 equals to y plus 3 the whole square. Now, if I want to take square on this side, it becomes square root, right? So if I'll take square on this side, it will become square root. So let us take square on this side, and let me do it here. So here, square root of 36 is equal to y plus 3, right? Because I have taken square on the other side, which will become square root. What is square root of 36? Here we need to consider both the cases, because these are coordinates. Coordinates can be negative as well as positive, right? So square root of 36 is plus or minus 6. It can be plus 6 also, because the square of plus 6 is 36 and square of minus 6 is also 36, right? Because minus 6 into minus 6, which is plus 36. So square root of 36 is plus or minus 6 equals to y plus 3, right? Now easy, we can figure out the value of y by sending this plus 3 on this side, right? So it will become minus 3 and we'll get the answer. But we need to consider once plus 6 and we need to consider the other time minus 6, right? So let me write down here both the cases. 6 plus 6 equals to y plus 3, or I can say minus 6 equals to y plus 3, right? Both the cases I have written it here. Now taking plus 3 on this side, so 6 minus 3 equals to y, and 6 minus 3 is 3 equals to y. So one of the value of y is 3. And solving this, we'll get minus 6 plus 3 taking on this side. So minus 3 equals to y. Minus 6 minus 3 is minus 9 equals to y. So the second value of y is minus 9, right? So we got two answers here for y, which is 3 as well as minus 9. So I can say that 2 comma minus 3 is the point P. Q will be 10 comma 3, one of the point, 10 comma 3. So the distance between 2 comma minus 3 and 10 comma 3 will be 10 units. Or else if you figure out the distance between 2 comma minus 3 and 10 comma minus 9, substituting y equals to minus 9, then also you will get distance PQ as 10 units, right? Because you can have same distance at between multiple points on the graph, right? So here we are getting two values for y, which is 3 as well as minus 9. Again reiterating, we were given 2 points. In the second point, the y coordinate was missing, but the distance between the 2 points was given to us, which was 10 units. So we have applied the distance formula here, and thus we have substituted as 10 because it was already given, the distance is 10 units. Now solving it further, okay, what we are getting it as, we are getting two equations, y plus 3 equals to 6 and y plus 3 equals to minus 6. So we'll get y as 3 as well as minus 9. So that means the y value is 3 as well as minus 9, right? So this was the last important question of this exercise which we have picked. So yeah, that's it for this video. In the next video, I'm going to cover section formula. Based on the section formula, we are going to see midpoint formula also, and then we will see a few important questions from exercise 7.2. So yeah, that's it for this video, and you can catch me up in the next video. Thank you.